In this lesson, we're going to talk about rate of change and slope. So first, let's talk about rate of change. So rate of change is when you look at a function table like this one, and you're going to look at how the y values change and compare them to the way the x values change. And so basically, you are setting up a ratio, a fraction, and the numerator is going to be the change in y, and the denominator is the change in x. So if we look over here and we look at our y values, from 0 to 3, that's a change in plus 3. From 3 to 6, that's a change in plus 3. From 6 to 12, that's a change in 6. And from 12 to 15, that's a change in 3. Now let's look at our x values. From 2 to 3, that's a change in 1. From 3 to 4, that's a change of 1. From 4 to 6, that's a change of 2. And from 6 to 7, that's a change of 1. And if I made fractions out of all of these, y over x, so I get 3 over 1, another 3 over 1, I get 6 over 2, and I get another 3 over 1. So basically, what do I have? All of these are the same, and even this 6 over 2, if I simplify it, I get 3 over 1. So the rate of change for this table is 3 over 1, and we can simplify that and just say it is a change of 3. So the rate of change for this function table is a rate of 3. And the fact that we see that the rate of change for each step is the same, this is what's called a constant rate of change. So now let's go ahead and plot these points on this coordinate plane. We have 2, 0. It's going to be right here. We have 3, 3. That's here. 4, 6. That's here. 6, 12. That's right here. And 7, 15. That's right here. And so if we take a straight edge and line these points up, we see that they make a straight line. So this is a linear function because when we graph it on a coordinate plane, we get a straight line. So now we understand that a constant rate of change equals a linear function. That's how you get a straight line on a graph, is if you have a constant rate of change. We saw that this function has a constant rate of change of 3 over 1, or just 3. So now we can see what slope is, because slope is merely the rate of change of a line, of a linear function. And we remember that the constant rate of change for this table is 3 over 1, and that is the slope of this line. Now slope is, again, another fraction, which is the change in y, known as the rise, over the change in x, known as the run. So remember here, our rate of change was 3 over 1. And so let's go ahead and take a look at the rise and run of this line here. So to get to this point, I had to move up 1, 2, 3. That's my change in y, over 1 to the right. That's my change in x, 3 over 1. Same thing to get to the next point. Up 3, 1, 2, 3, and over 1. Once again, that is 3 over 1. To get from this point to this point, I had to go up 6 and to the right 2, which simplifies to 3 over 1. So there we can see that the rise over run of this line is the same as the change in y over change in x for this table. And that is what slope is. So there are 4 types of slope. Now it's important to remember how we read graphs in math. We read graphs in math the same way that we read words in the English language. So we read our graphs from left to right. So when we talk about the rise of a line, we're talking about how that line moves up or down. And when we talk about the run of the line, We're talking about how that line moves from left to right, not from right to left, only from left to right. And once again, that's because we read our graphs in the same way that we read words in the English language, from left to right. So if we look at this first graph here, we notice that it is moving upward as it travels from left to right. So think about if your grades are going up, that's a good thing, right? That is positive. So this is a positive slope. This second line here, this red line, is moving downward as it moves from left to right. And again, if your grades go down, that's not very good, right? That's negative. So this is a negative slope. Now look at this green line here. This green line is moving straight across. It's not going up or down. It's staying at the same height as it moves straight across from left to right. So you would say that this almost has no slope. Well, which number in math kind of means no? We would say 0, right? So this has a 0 slope. And this pink line here is going straight up and down vertically, right? Now think about it. Is it traveling from left to right? No, right? So you really don't know if it is going up or down because it's not traveling from left to right. So this slope is undefined. All right, so let's go ahead and find the slope of some lines by counting. So what we want to do is we see that we have this line here, this blue line, and it's going up from left to right. So we know that this is a positive slope. And so what we need is we need some points that we can count to get from one point to another. So when they don't give you points, what you want to do is you want to look at the grid marks and you want to find some points that are easy to identify. Like right here, this is an easy point to identify. Here's another one, and hopefully you're starting to see the pattern here, right? And I'm going to skip a few here. I'm going to go to this one, right? And so now you can do that. What you can do is you can use these points to count how many steps it takes to get from one point to the other. Now remember that we are talking about rise over run. So that is our change in y over our change in x. So we want to make sure that we're putting the numbers in the right spot. One of the places where students usually have trouble with this is they flip the fraction upside down and they put the numbers in the wrong spot. So first, my top number is how this line moves up or down. We've already discussed that it is moving upwards from left to right. So to get from this point to this point, it is moving up 1, 2 steps. And it is moving to the right 1 step. And if I count here for the next point, I see that again, up 2 and to the right 1. And up 2 and to the right 1. So that is a slope of 2 over 1. Well, how about here, this big gap that I skipped here? Well, to get from this point to this point, I'm moving up 1, 2, 3, 4, 5, 6, and to the right 3. And that's still the fraction 6 over 3, which equals 2 over 1. So the slope of this line is 2 over 1, which can be simplified to 2. So this line has a slope of positive 2 because the rise is 2 steps over a run of 1 step to the right. So this next line here, we can see that it is traveling downward from left to right. So this is going to have a negative slope. And once again, they don't give us any points to work with. So we can go ahead and look for our own areas where the line intersects nicely on the grids. So here's a nice point to work with. And if I follow, oh, here's another nice point to work with. And here's another one. And here's another one. And here's another one. And so this line is moving down, but our top number is still our change in y. So this line is moving to get from this point to this point. I have to move down 1, 2, 3 steps. So that is going to be a negative 3 over, and then it's going to move to the right 1, 2, 3, 4 steps. So the rise of this line is it's going down 3, and the run is to the right 4. And we could check again. We go 1, 2, 3, down 3, and 1, 2, 3, 4. And again, down 3, 1, 2, 3, and to the right 4. 1, 2, 3, 4. And one more time, down 3, 1, 2, 3, and to the right 4. 1, 2, 3, 4. So we see that the slope of this line here is negative 3/4. Always beware when you're doing this of the scale that's being used on the coordinate plane. The first two examples I gave you were easy because they were counting by 1 for the x-axis and the y-axis. But notice that this one is counting by 2's. So you just have to be very careful when you are counting to find the slope. So here we see that this line is traveling upwards from left to right, so we know it's a positive slope. So let's get our rise, which is again the change in y. So to get from this point to this point, notice again that this scale is counting by 2's. So a half a step is 1. So this is going to go up 1, 2, 3, 4, 5, 6. And then to the right, 1, 2, 3, 4, 5. Again, because the scale is counting by 2's. So here, the slope of this line is 6/5, which can also be written as 1 and 1/5. However, it's perfectly acceptable to leave your slope as an improper fraction as long as it is in simplest form, because really what's going to happen is if you're working on a problem and they give you a slope of 1 and 1/5, the first thing you're going to do is reconvert that back to 6/5. So now there is a way to find the slope of a line without having to count on a coordinate plane, and that's called slope formula. And it's right here. M equals y2 minus y1 over x2 minus x1, where m is the variable that represents the slope. So what is this y2 minus y1 over x2 minus x1 all about? Remember that slope is the rise over run of a line. And the rise of a line is the change in y. What's another way to say the change in y? Well, the difference between the two y values. Because we see here we have 2 points, that means we have 2 y values. And how do you find the difference between two numbers? You subtract. So y2 minus y1 means the y from the second point minus the y from the first point. And the run is the same thing. It's the difference between the x values of the 2 points. So again, x2 minus x1 means the x from the second point minus the x from the first point. And that gives you your slope, which is the rise over run. Now, when you're doing slope formula, it actually doesn't matter which point you consider the first point and which point you consider the second point. All that matters is that you're working in the same order on the top and the bottom of this fraction. So the first thing you want to do is you want to copy down the order pairs for each point, like I did here, and then you want to take one point and label it as x1, y1, and take the other point and label it as x2, y2. And once again, it does not matter which points you label x1, y1, and which point you label x2, y2. The next thing you want to do is rewrite the slope formula using parentheses for your values. So that's going to look like this: m equals, and I'm going to put a parentheses for y2 minus my parentheses for y1 over my parentheses for x2 minus my parentheses for x1. Now the reason you want to do this is because one area where students commonly make mistakes in doing slope formula is in dealing with negatives and double negatives. So using parentheses is always a good way to help you avoid making those mistakes. So now I'm just going to go ahead and plug these numbers in. So y2 minus y1, my y2 value is 3, and my y1 value is -1. And x2 minus x1, my x2 value is 2, and my x1 value is -2. Now notice these double negatives here. This is why the parentheses are so important. So 3 minus negative 1 becomes 3 plus 1, and 2 minus negative 2 becomes 2 plus 2. Now 3 plus 1 is 4, and 2 plus 2 is 4, and 4 over 4 simplifies to 1. So this line has a slope of positive 1. So what does that mean? Remember that slope is a ratio, is a fraction of rise over run. So even though we've expressed this slope as a whole number, I can write the whole number 1 as a fraction of 1 over 1. So what that tells me is that this line moves up 1 unit as it moves to the right 1 unit. So if I start at this point here and I move up 1 and right 1, you see how I end up right back on the line. If I do it again, up 1, right 1, again back on the line, up 1, right 1, back on the line, and up 1, right 1, I've arrived at this point. So hopefully this helps you to understand what a slope of 1 means. So with slope formula, you don't need the coordinate plane and you don't even need to see the graph of the line. All you need are any 2 points from that line. So you see here we have this table and we have 4 points. So I'm just going to pick the first 2 points. So I'm going to pick 3, 2 and 3, 4, and then I'm going to go ahead and label them. I'm going to label one of them x1, y1, and I'm going to label the other point x2, y2. Now I'm going to write the slope formula using parentheses. So y2 minus y1 over x2 minus x1, and I'm going to plug in my values. So y2 is 4 minus y1 is 2 over x2 is 3 minus x1 is also 3. So what is 4 minus 2? That's 2. And what is 3 minus 3? 0. So what would happen if you punched 2 divided by 0 into your calculator is your calculator would say error. And why is it? Because you cannot divide by 0. Now 0 divided by anything equals 0, but you cannot divide by 0. So this slope is actually undefined. So the graph of this line would actually be a vertical line that passes through the x-axis where x is equal to 3. Now how do I know that? Look at all the x values. 3. And this is an undefined slope. Alright, so let's take a look at 2 more examples. I would encourage you to pause and try it on your own and then come back and see if you got it right. So this first line here, I see I have 1 point at -1, 9, and I have another point at 2, -5. So I'm going to label x1, y1 and x2, y2, and then I'm going to set up my formula to work this out. So m equals y2 minus y1 over x2 minus x1. So my y2 value is -5 minus my y1 value is 9. My x2 value is 2 and my x1 value is -1. Now -5 minus 9, that is -14, and 2 minus -1, that becomes 2 plus 1, and so that's +3. So the slope of this line is -14 over 3. And once again, you do not need to write it as a mixed number as long as it is in simplest form, which this is. And if you notice, this makes sense. We can see that this line is going down from left to right, and notice that our answer when we found the slope using the formula is a negative number. And now in this example here with the table, again I have 4 points and all I need to do are pick any 2 of them. So I'm going to pick these 2 points in the middle, and I'm going to take one. I'm going to say okay, 2, 5, and 3 comma 5, and I'm going to label them x1, y1, and x2, y2. Then I'm going to go ahead and set up my slope formula. So m equals y2 minus y1 over x2 minus x1. Let's plug these numbers in here. So y2 is 5 minus y1 is 5, and x2 is 3 minus x1 is 2. 5 minus 5 is 0, and 3 minus 2 is 1. And 0 divided by anything is 0. So the slope of this line is 0, which means that the graph of this line is going to be a horizontal line that does not move up or down as it moves from left to right. All right, next, let's take a look at some real-world situations, find the slope, and then interpret that slope in the context of the real-world situation. So if we look here, it says, the graph shows the relationship between a person's age and his or her estimated maximum heart rate. So let's go ahead and find the slope here. We have 2 points. We have 20, 180, and we have 50, 150. So I'm going to label one of these as x1, y1, and the other one as x2, y2. Then I'm going to set up my slope formula. So m equals y2 minus y1 over x2 minus x1, and plug in these numbers. So my y2 value is 150 minus my y1 value is 180, and x2 is 50 minus x1 is 20, and 150 minus 180, that's negative 30, and 50 minus 20, that's positive 30. So this slope is negative 1. And remember that a slope of negative 1 can be written as the rise over run fraction of negative 1 over 1. So then let's interpret this slope of negative 1 in the context of the problem. Now the best way to do that is to look at your y values, because we know that our top number is our change in y and our bottom number is our change in x. So if we look at our y-axis, that is the maximum heart rate in beats per minute. And if we look at the x-axis, that is age in years. So what does this negative 1 mean? This means that our maximum heart rate in beats per minute is going down 1 as our age increases 1, right? So the slope of negative 1 here in this problem means that with each year that we get older, our estimated maximum heart rate drops by 1 beat per minute. All right, one last example. It says here the number of cubic feet of water, Y, in a reservoir X hours after the water starts flowing into the reservoir is a linear function. The points 40, 3000 and 60, 4000 are on the line of the function. So let's go ahead and find the slope. And if you notice here, the points are right here nicely written for me, so I'm not going to write them over. I'm just going to label them. So I'm going to call this point x1, y1, and I'm going to call this point x2, y2. And let's set up our formula. So m equals y2 minus y1 over x2 minus x1. So my y2 value is 4,000, and my y1 value is 3,000, and my x2 value is 60, and my x1 value is 40. And here 4,000 minus 3,000 is 1,000, and 60 minus 40 is 20. And 1,000 divided by 20 is 50. So the slope of this line is 50, which again, as a fraction, that would be 50 over 1, and it's positive, so this is up 50, right 1. So let's interpret that. So knowing that our y value is cubic feet of water, and our x value is hours, what does this tell us? Well, the amount of water in the reservoir is increasing by a rate of 50 cubic feet of water for every hour. All right, hopefully you understand how to calculate and use slope.